Hello everyone and welcome to my YouTube channel. Myself Pranit Mehta, lecturer from St. John College of Engineering and Management, Palghar. In this video, we will discuss about the moment of inertia of some standard shape. Learning outcomes. Learner will able to know moment of inertia of standard shapes. Learner will able to solve numerical based on a moment of inertia. So the first standard shape is a rectangle. So here this is a rectangle having dimensions b as a width and d as a depth, and C is the center of gravity which is located at the intersection of x-axis and y-y axis. So now the area of a rectangle is given as b into d. Then the distance of a CG from x and y axis is given as, so these are the distances. X is the distance of a center of gravity from y axis and y is the center of distance of a center of gravity from x axis, which is given as x is given as b by 2 and y is given as d by 2. Then the moment of inertia about x-axis for a rectangle is given as I-axis is equal to bd cube by 12, and the moment of inertia about y-y axis for the rectangle is given as db cube by 12. Then the next standard shape is a hollow rectangle. So this is a hollow rectangle having inner dimensions of a width as a pi and inner dimensions of the depth as a ti. The outer dimensions for the width as a p0 and for the depth is d0, and C is the center of a gravity or the centroid for the hollow rectangle. Then the area of a hollow rectangle is given as outer dimensions minus inner dimensions. So here b0 d0 is outer dimensions minus bi di is the inner dimensions. Then the distance of a CG or the distance of a centroid from x and y axis for hollow rectangle is given as xc is given as b0 by 2 and yc is given as d0 by 2. Then the moment of inertia for a hollow rectangle about x-axis is given as I-axis is equal to b0 d0 cube by 12 minus bi di cube by 12. Then the moment of inertia about y-y axis for a hollow rectangle is given as Iyy is equal to d0 b0 cube by 12 minus di bi cube by 12. Then the third standard shape is a circle. So this is a circle having d as a diameter, c is the center of gravity which is located at the intersection of x-axis and y-y axis, and xc and yc, these are the distances of a centroid from the respective axis. So the area of a circle is given as pi by 4 d square. Then the distance of a CG from x and y axis is given as x is given as d by 2, y is given as d by 2. Then the moment of inertia for a circle about x-axis is given as I-axis is equal to pi by 64 d to the power 4, and the moment of inertia for the circle about y-y axis is given as Iyy is equal to pi by 64 d to the power 4. Then the next standard shape is a hollow circle. So this is a hollow circle having di as the inner diameter and d0 as the outer diameter. C is the center of gravity located at a intersection of x-axis and y-y axis, and xc and yc, these are the respective distances of a center of gravity from the axis. So the area of a hollow circle is given as pi by 4 d0 square minus pi by 4 di square. Then the distance of a CG from x and y axis for the hollow circle is given as xc is equal to d0 by 2 and yc is equal to d0 by 2. Then the moment of inertia for a hollow circle about x-axis is given as I-axis is equal to pi by 64 d0 square minus pi by 64 di square, and the moment of inertia for the hollow circle about y-y axis is given as Iyy is equal to pi by 64 d0 square minus pi by 64 di square. The next standard shape is a rectangle. So this is a rectangle having h as a height and b as a base. The CG is located at a distance of h by 3. So this is a CG which is located at a distance of h by 3 from the base. Then the area of a triangle is given as 1 of base into height. The distance of a CG the distance of the edge from the base yc is given as h by 3, and if we want to find the center of gravity or the distance of a edge from the top of the triangle, which will be given as 2h by 3. Then the moment of inertia of a triangle about x axis is given as Ixs is equal to bh cube by 36. If we want to find the moment of inertia about of a triangle about the base PC, so this is the base about which if we have to find moment of inertia, so which will be given as I base is equal to bh cube by 12. And if we want to find moment of inertia for a triangle passing through the axis about its apex, so this is the apex about which we have to find moment of inertia for the triangle, which will be given as bh cube by 4. So this is the I apex, which is given as bh cube by 4. Then the next standard shape is a semicircle. So this is a semicircle having R as a radius, C is a center of a gravity. Then the area of a semicircle is given as pi by 2 r square. Then the distance of a circle from the base, so this is the C, which will be located at a distance of 4r by 3 pi from the base. So OX is the base and C is the distance, or the C is the center of gravity, which will be located at a distance of 4r by 3 pi. Then the moment of inertia about x-axis axis for the semicircle is given as Ix is equal to 0.11 r to the power 4, and the moment of inertia for the semicircle about y axis is given as Iyy is equal to pi by 8 r to the power 4,